artists, fiction writers, movie makers, they dream. Some of them get paid very well for doing so. But in an implicit manner, they also challenge the researchers and engineers to make their dreams a reality. Starting from Valmiki's Pushpaka Vimanam to Vedavyasa's television, where Sanjaya is watching Kurukshetra battle happening far, far away, and then giving live commentary to Dhritarashtra, there are many interesting imaginations that inspire the scientific progress. The picture that you are seeing is that of a computer called HAL 9000, an imagination of Sir Arthur Clarke and Stanley Kubrick for the Space Odyssey series of movies and novels. This is the first fictional computer that got nominated to the Robert Hall of Fame in 2003. Giving company to this computer are two other computers called R2-D2 and C3PO from the genius of George Lucas from the Star Wars movie. So what is common for all these machines is that they have this very desirable attributes of a synthetic creature to coexist and serve humans. So this talk is about a scientific journey of my own and some of my colleagues at IIIT Hyderabad and students to make the dreams of some of the greatest movie makers and fiction writers a reality. So that's about realizing HAL and other computers through what we call as the SILKy computing. I'm borrowing the word SILKy computing from Professor Raj Reddy's proposal on SILKy interfaces, where we use speech processing, image processing, language processing, and knowledge processing, combine all of them to create something very, very interesting. So these are all part of a puzzle that we're going to solve one by one. Let's start with the speech processing. Like the speech puzzle, first part is the speech synthesis, where you are making computers talk. So if there's a piece of text, the computer will transform that text to speech. And then speech recognition, this is making computers understand what you're talking so that it will do further processing, whatever that is required. And then an interesting piece of work in speech is conversion of voice. I grew up listening to stories from my grandfather, and somehow I liked the deep voice and then the musical rhythm while he was telling me all those stories. So if I'm listening to an audiobook, I would like to hear that audiobook in the voice of my grandfather rather than the source in which it was recorded. Right? So looking at this, we have a target speaker.
The ship should be in within a week or 10 days.
But then what I have is another voice in the original recording of the audio.
He turned sharply and faced Gregson across the table.
So I would like to hear the story that is coming in the voice of the original person, whose voice is my favorite.
He turned sharply and faced Gregson across the table.
So this is about the voice conversion research that actually can do wonders. For example, you can hear your email in Amitabh Bachchan's voice or your grandmother's voice. Then the image processing puzzle, and this is about the optical character recognition and then what we call as the handwriting recognition, either while you are writing or once it is written and available. So with this, what is possible are again very, very interesting. So we have built a system called Sanjaya, where you actually put a newspaper clipping in Indian languages like Telugu or Hindi, and then a scanner takes the image of that, and that image is given to the computer, which processes it and then converts that to speech, and then you get the speech output from the scanned news image all at the same time. So these are interesting possibilities. And then the language puzzle. So all human beings, we are very gifted to have this unique ability to communicate with others in such a sophisticated manner in terms of creating language as well as understanding and processing language. So what it means to enable computers to understand language, understanding words, phrases, sentences, paragraphs, text, whole book. It actually means it not necessarily understand the way humans understand, but in the way that actually can process it further is an important aspect of making computers understand natural language. And then once we have an understanding of the language, it's possible perhaps to make machines translate from one language to another language. And then in order to do that, we also need the language generation capabilities. For example, if from an intermediate representation of a piece of information, you are generating language in whatever the natural language that you are looking at. So with this, we have built a system called Sampark. Sampark system is a machine translation among Indian languages. There are currently 8 pairs of languages that are available, which can be tried out. It's available. And then here, you basically choose, it's a cut and paste some text, and then that text gets displayed, and then you have the machine translation system which translates into the target language, and then you have the target language output. So this is the system that is developed in collaboration with 18 pairs of languages will be available soon. So here we chose to do the Punjabi text and then choose to translate that into Hindi, and then you have the translated version of Hindi text. Now, combining language technologies with speech technologies again gives us very interesting possibilities. Think that I'm a person who speaks only Hindi, sitting in Gwalior, and then I suddenly discovered my lost cousin who grew up in Warangal speaking only Telugu. So I pick up a phone and then speak in Hindi. By the time the signal reaches him, it's actually translated to Telugu, and he hears in Telugu. When he speaks back and he responds in Telugu, by the time signal reaches me, I hear it in Hindi. So it might sound too fictional at this point in time, but actually we have a demonstration that makes it possible in a limited environment. So all of us know about 108 emergency response system. Here is a situation where a call center person can actually speak Telugu.
कर्नाटक में फ्लाईओवर के पास एक एक्सीडेंट हुआ। ఎంతమంది గాయపడ్డారు? 3 लोग घायल हुए। మా సిబ్బంది తొందరలో మిమ్మల్ని సంప్రదిస్తారు.
So here you saw an example where there's an online machine translation system between 2 Indian languages. But then other more important puzzle is that of knowledge puzzle. So we have internets, intranets, huge repositories of knowledge that are available to us. And then we have social networks where people collaborate with each other in creating the content as well as consuming that content. And then semantic web is coming, where the knowledge is going to be accessed not only by the human beings, but also the other cyber creatures. And then perhaps we are going to see very soon what we call as the ubiquitous web. That's where computing and knowledge becomes available whenever people need it, wherever they need it. Now let's look at the internet and intranet aspects. Right? This is what we call as Web 1.0. So we all know that the entire information that is available is getting organized, and there are tools to access them. So you're happily Googling, then you have Cool, you blink, and then you have Bing. The pace at which the innovation is happening in this space is so exciting. That's really wonderful to work in these areas. And then when the world is making so much progress in other for Western languages, we can't be sitting idle. So we have developed a search engine for Indian languages that is in turn licensed to, in this case, Rediff, but also many other companies, where the technology that works for English and other Western languages not necessarily can work for Indian languages, because our languages are more sophisticated with the sophisticated formation of the words, sentences, and so on. So we have very unique problems, and it is us who have to solve those problems. So, but whatever that works for Indian languages can perhaps work for many other languages in the world. So this is how this experiment has proved to be true. So with the same technology that worked for Indian languages, when we tried to make it work for many other languages in the world, we were successful in building technologies, the search engines in 23 world languages, starting from Arabic to agglutinative language like Finnish. So essentially, the knowledge puzzle in terms of the internet and intranet are getting solved, and but at the same time, it continues to be a very exciting area. Then comes the social networks, right? So which is what we call as Web 2.0. And then tools like Facebook, Twitter, Flickr, YouTube change the game forever. So here, in the earlier Web 1.0, it is few writers and many readers. In this case, there are many readers and many writers collaborating at the same time and producing content that is useful. So if you're looking at the same content that is coming from the social networks, and then if you do a regular search, and then you get the scoop of what is happening in your neighborhood. For example, TEDx event comes from the social search, not from the regular search on Gachibowli. In the same space, we also built tools where documents that belong to a narrow domain are organized, and then information gets extracted, and that information is used to generate content in an automated manner. For example, in this case, there is a content that is being generated completely automatically by a computer program, and then this content can be given to can be viewed by the humans, and then they can add to that content in order to make it more useful. So in a true sense of collaboration, computer programs and human beings are working together in order to create content that is useful to the rest of the world. Now, more exciting period of knowledge processing is beginning. So it is Web 3.0. So we all know that a lot of knowledge that is embedded in the text or in the documents, movies, pictures that exist in the web. But then we all can see it, but we can see so much in our interaction through a browser. What if computer programs can be written which will go and access all that knowledge and then lets us know what exactly that we want instead of us spending time exploring that content. So this is where there are tools that are being built to process the concepts of the content that exists on the web instead of looking for regular keywords. So in this case, we asked about we asked for get more information about Shah Rukh Khan, right? So it went and found recognized the concept called Shah Rukh Khan, not the keyword Shah Rukh Khan, and then all the concepts that are related to this particular concept. So for example, Shah Rukh Khan's visit to USA, Shah Rukh Khan, Gauri marriage, and so on and so forth. And then it's also finding the relationship that exists between all these concepts. So as the relationships are coming, and note that all these relationships are not same, there exist several kinds of relationships between all these concepts. And then when put together all these, everything cannot be shown in this visual because the internal representation is much more complex than what you're looking at. So in that sense, we now have the ability to query the web, which is a huge repository of knowledge that ever existed since the humankind, the same way that you query a regular database, a regular structured database. So this gives us a lot of power to make our computer programs much more powerful then we got to get our imagination back after doing all the hard work, right? So where to go? Definition of how Google would look like, or any search engine would look like in 2084. So you can feel lucky or you can feel paranoid. You can search in your brain, the way you have the matrix-like plugins, or you can search whatever is in your home. So you can say, where are my car keys? And it says on your refrigerator, right? It knows better. And then also you can search your past, present, future. You can search on the satellite photos of the people who want to spy on you, right? So it's limitless. So now coming back to the reality, but through SILKy computing, we can make many of these dreams come true. For example, as I said, speech recognition and speech synthesis to interact with the computer in the most natural way that is possible, the most natural way that we interact with other human beings, and then image processing in order to give much more richer input, interactive way of communicating with the machines, and then knowledge processing in terms of using the web as a knowledge repository the way you use any regular structured database, enabling that knowledge processing with the help of language processing, which is so natural to human beings, but then can be taught with some level of difficulty to the machines. Thank you.